A harmonious subsequence only cares about two adjacent values, so we can count frequencies instead of checking every pair. We're given an integer array. A subsequence is harmonious when the difference between its largest and smallest element is exactly 1. The task is to return the length of the longest such subsequence. For example, with the array 1 3 2 2 5 2 3 7, the longest harmonious subsequence is 3 2 2 2 3 5 elements long. The straightforward way is to pick each element as a possible minimum, then scan the whole array counting how many times that minimum and the minimum plus 1 appear. If both counts are positive, we update the answer. This double loop runs in big O of n squared quadratic time while using only constant extra space, which quickly becomes too slow for large inputs. The key insight is that we only need the frequency of each distinct number. First, we build a map from value to its count by iterating once through the array. Then we iterate over the map entries. For each key, we check whether the map also contains key plus 1. If it does, the combined count of the two keys forms a harmonious subsequence, and we keep the maximum of those sums. This single pass to build the map and a second pass over the distinct keys gives us the answer. Let's trace the optimal method on the example. We start with an empty frequency map. Scanning the array, 1 appears once, 3 appears twice, 2 appears 3 times, 5 once, 7 once. The map now holds 1 maps to 1, 2 maps to 3, 3 maps to 2, 5 maps to 1, 7 maps to 1. Next, we examine each key. For key 1, key plus 1 is 2, which exists, so candidate length is 1 plus 3 equals 4. For key 2, key plus 1 is 3, candidate length is 3 plus 2 equals 5. This becomes the new maximum. Keys 3, 5, and 7 have no neighbor in the map, so they don't improve the result. The final answer is 5. You'll recognize this pattern whenever a problem asks for a substructure defined by a simple relationship between two values, like difference equals 1, or sum equals target, because a frequency map lets you evaluate the relationship in constant time per distinct value. Time complexity is big O of n because we traverse the array once and the distinct keys once. Space complexity is big O of n in the worst case for the frequency map. Try the next problem, same frequency map pattern. Subscribe for more DSA walkthroughs.